What up, guys? This is FRC Coding Class Day 9. This is the last class of the FRC Coding class, um, and we will be covering writing subsystems. Basically, um, as I mentioned before, subsystems represent specific parts or sections of the robot that we can use to simplify and spread out the robot code into different places that makes most sense. Subsystems are located inside this package right here. Dot subsystems is what I probably will refer it to as, and each subsystem will contain its own class or .java file. Okay, so in each class, there's a super strict structure in order to keep them similar across subsystems. So each subsystem, when you open up the file, should obviously be a subsystem, and they should all look quite similar. So the way we've achieved this is dividing them into a few sections: variables, loop, debug, internal functions, external functions, config, and reset. And sometimes there's more. Usually there's just these. And it may seem like a lot of sections, but this is the way we found so far to get the best organization and flexibility. So the first section is variables. The other sections have labels with a little comment like slash slash whatever. This doesn't, just kind of for simplicity, and it's at the top, so it doesn't really need it. And it contains all the different variables for the class. This is only for variables though, so anything that's like constant and doesn't change is all going to be located inside constants.java. So things that you might see here is motor controllers, solenoids, and then other kind of variables you might use in your code, like random booleans or integers. The next section is loop. This is labeled with like slash slash loop on top, and there's an extra space between the last section. There's only one method in here, like a few of them, and it's just called update. And basically, this method gets called while the robot's enabled repeatedly every 20 milliseconds, which is called 50 hertz. And the goal of the method is to figure out what the state is of the superstructure, basically the requested state. Like the superstructure is like, you should be intaking, what do the sensors say, and then give corresponding motor output and solenoid output, or whatever else you're going to be doing in there. And so what this might look like is a superstructure manual automatic. That's something I don't think I covered too much in the superstructure. Basically, usually it'll be automatic, but manual basically means it's like an emergency mode. Like, let's say some sensors disconnect, you'll like, a backup mode is you like go into manual and you want some functionality, but basically most things won't work. So for a lot of things, it'll say if it's automatic, do the normal code, otherwise just stop everything, as a safety mode, basically. Then inside there, modes are basically like intake, idle, shoot, things like that. And so then you'll like kind of, if intaking, then do this, etc. down the line. Another thing you might see is a fast loop in turret.java or hood.java, and it's identical to the loop section, except it says, fast in front of it. Basically what that means is it's running at double the speed, and it's not completely integrated into the code base. I kind of just started it, but never got to finish it. It's usually a lot better to run control loops, like a PID loop, at as fast as you can, basically. Obviously limited by how fast the sensor can update. But I didn't fully integrate it, so right now it's just used for like super fast limit switches response. I cannot talk today. Jeez. Debugging is the next section. Basically, it has one method called debug, and that call gets called at the same rate as update and at the same time as update, but it's only called if the subsystem is in debug mode. So if you remember, in robot.java, you can add a list of subsystems to the inside the .debug function, and then all those subsystems will be labeled as debug, and then this function will get called. The goal of this method is to make it so you don't have to keep like adding or removing tuner methods, because it used to be, before we had debug, is like, okay, I'm gonna tune the turret, and so now I'm gonna just like uncomment like 20 lines of code, and it just makes a lot of things really messy. So this helps bring that out of the code and makes it so you don't have to comment and uncomment a bunch of code. Okay, so panel or example of this, I cut out some of the code because it's not like relative to this, but basically, as I said here, is for this, if it's manual automatic, it doesn't really matter because the subsystem doesn't need an encoder from what I remember. And then on here, you can call get mode, and then it depending on the mode, it'll switch between different things. Internal functions is the next section. It goes hand in hand with the external functions, which is the one below it. Basically, these both group all of the subsystem specific methods. So if you ever have a method that's very like only for that subsystem, or maybe it's similar across others, but it's not in all of them. Basically, how I call it is the other methods like loop and I guess that's all we talked about so far, or would be default methods. These aren't default because they're not on every single subsystem. Internal functions are ones that are only going to be called within this class. Basically, it just helps kind of move some code outside places it doesn't need to be, or reduce repetitive code. It's a good habit to put everything that isn't used outside the class into internal functions, basically, just to be safe. Basically, at bare minimum, everything that would be basically, if something could go bad, if something acts randomly called it has to go in here. Like, for example, if I reset the encoder on the turret would think it's at 0 degrees when really it's at 200, and then it would just turn at full speed until it hit a limit, a physical limit, and it would probably break something. So don't put that there. Don't put motor speeds in here. So I shouldn't be able to control the motor outside the method because mistakes happen sometimes. Code gets written in places it shouldn't be, or multiple things call it. Basically, if you're ever going to set the motor speed or reset the encoder, it has to be inside that method. So make it an internal function. It's mainly for setting motor speeds, moving pistons, and resetting encoders. Okay. Here's the example. Basically right there. External functions. So as I mentioned before, external functions are all the functions that can be accessed from anywhere in the code base. Like you can't say, I only want this class to access it. It's either it can get called only in this subsystem or everywhere. So this is why you want to be super careful about this. Usually, if you're gonna have a function external, it's like something like reading a value. So if I were to again accidentally call it, it doesn't matter. So something like, is this subsystem like, is it at the limit? Like, can it go back any further? Or what's the value of the encoder? Reading the value of the encoder doesn't affect anything, but resetting the encoder does. And here's an example. So is finished, this is for the paneler. So is it finished rotating the panel? Yes or no, basically. And if I read that accidentally, it won't affect anything. And same for this other function here, which is reading an encoder. Config is the has one method called a init, and it's the first thing that gets called. So as soon as inside the subsystem, so as soon as the robot boots up, this method gets called. The goal here is to create all the new objects for different devices associated with the subsystems. So inside the top section, variables, there you would make like your motor controller object, your solenoid or variables, and your solenoid variables, but you don't actually instantiate them. Instantiating is when you call like new double solenoid, new Talon extracts. You don't want to say that in variables. You want to say that in the init function, and the reason is because if you don't enable a subsystem inside robot.java, but you have new inside the variable section, it'll still like create those devices. And if you have the subsystem unplugged, it'll just cause a bunch of errors. Basically, anytime you want to instantiate things, put it in init. in subsystems. And make sure that you store all your device IDs. So instead of just saying like in the init function like new Talon SRX 12, you want to say new Talon SRX ports dot drive L1, and that makes it a lot easier to read. And then it's labeled, and then all the device IDs are in port.java, not just kind of randomly scattered across the different subsystems. This method should also be used to set up all the settings on the device. So for Talons, what you want to do is make the Talon device, reset it to factory default just to be safe, and then set all the settings all the different settings you want. So motion magic, or I guess you probably don't know what that is, but a bunch of different settings you could set on these devices. Here's an example for the paneler. This one's pretty simple, but when you get into more complicated subsystems like the turret, it's a lot more code here. Oh yeah, resetting encoders is also a good one here. This right here is a Talon SRX, and then this configs it to the factory default. The final function in the code is called a reset. The section is called reset, and the method is called disabled. Basically, this disables the subsystem. It's a safety feature. So there's not too many things. There's not a whole lot of safety features because a lot of it is already coded, like hard coded into the robots. But this is one that we've made, and so please take precautions here. Basically, what could happen is, well, let me explain what it does. First, it'll set all the motors to stopped. Don't just like set the motor speed to 0. You want to actually tell the Talons to be disabled, and then bring the solenoids to a default state, whatever that might be. You can add some extra functionality like resetting encoders. Basically, this gets called whenever the robot's enabled or disabled. But the reason we have this especially is we have a mode where if you go into test mode, it'll run the compressor. But the thing is, this actually enables the robot. And so if the motors will stick at their last speed. So if we didn't have this and the motor was still at like quarter output when you disabled it, and now I'm like, oh, I'm gonna fill air. Everyone thinks filling air is just totally safe. Technically, it's not. When you're filling air, all the safety is up to us at that point. And so if we didn't have the disabled function and the motor's moving at quarter and you re-enable to fill air, it would still be moving. So that's a big safety hazard. So make sure you stop with the motors there. Okay, so outside the subsystem files, there are a few kind of setup things you have to do, and random code there might be. So again, there's a bunch of different constants there is. So inside constants.java and ports.java and controls.java, you're going to have corresponding code specific to that subsystem probably. There's also some superstructure code. The superstructure code is not that much per subsystem, and usually it's not subsystem specific, so some might not have any. Basically, it's like switching states out of certain events. So let's take, for example, the mode. I go into mode paneling, which will start spinning the control panel. And then what this function does here is if I'm in the mode paneling and the paneler says I'm done moving it, then it'll just return to idle and print that out into the console just so we can use that for debugging later. The teleop controller code for subsystems is going to go into superstructure.superstructurecontroller.java, and the goal of this again is to translate user input from controls.java into changes on the subsystems or in the superstructure. So this is what it looks like for the paneler. So if the button to deploy the paneler is right here, so if that gets pressed and the current mode is deploying or it's already paneling, it'll just stop. And then it'll print that out. Otherwise, it'll set it to deploying. And there's some other auto settings that'll basically move it. Once it's deploying, it'll move it to paneling with a sensor. Okay, that is the end of the class. I think this video was pretty fast. I didn't cover it too in depth, and that was kind of intentional because I feel like giving you all this information right now isn't going to be super useful. I just wanted you to have a brief understanding of how this works. Feel free to contact me about questions or any help you might need. I would also recommend these videos or slideshows as a reference to come back to. Um, there's a decent amount of commenting in the code if you want to look through that, or you're just really good at reading code. And then for all non-team specific things, so ignoring this class and the one before it, I'd recommend chatting on the FRC Discord. I think most of you don't know what that is. If you message me, I can give you a link to it. It's like 10,000 people or something. Not always not that many people active, but I use that a lot to learn a lot of this stuff. I think hopefully once you guys get back into the shop, you can get more familiar with this, and I can help you guys more. So that's the end of the class. Um, have a good one, I guess.